Hey class, how's it going? Here's video 2 about forces with angles. So we ended off talking about how to break down all these different things in the sense of we have still these formulas over here. Force equals ma, force friction equals mu times force normal. But this question looks very different than the ones with no angles for a couple of reasons. First, the actual object's not going to move in the same direction that you pull. It's not going to magically fly away. So we have to break this into two parts. And that was our force x and our force y. So that was the first part of why it was different. And then once we found our force x, we had to find force of friction. Okay, force friction, the formula is still the same. We still had a mu. Mu was given, which was fine. And then we had to use force normal. The thing is, force normal is also different in this question because your upward force that you're pulling with, your force y, is going to help the table. It's not going to feel the same force as if you were not pulling up. So that's why in the end our force normal looked a little different. So that's kind of a recap of our last video. Let's get into actually finding an acceleration, when we're actually trying to find an acceleration here. So we have our acceleration question mark. Okay? How do we find acceleration? Well, that's going back to our F, our net force, equals mass times acceleration. So we're trying to find acceleration. Just move the m over to the other side, and it's the force net, the net force over the mass. All right, well, we were given the mass originally of 20 kilograms. So that's the easy part. What is our net force here? Basically, is friction winning, or is the force applied in this direction, because that's the direction it's actually moving? Which one's winning? Well, we have 176.7 newtons in the Fx, and only 4.8, so obviously the Fx is winning by quite a lot. So to find net force is going to equal Fx minus force of friction. Okay, so for this question we have 176.7 minus 4.8. And our net force is going to be, I just have it over here, our net force is, where's our net force? 171, there we go, 171.9. So 171.9. So there is our net force. Okay, so cool. That's kind of our next step. And the last step, the very last step to actually find acceleration here, is to go take your F net and divide it by mass. So we're going to take that 171, decimal in the wrong spot, 0.9 over 25, and you get an answer of 8.6 meters per second squared. So this question, now that it's all fully finished, is very, very similar to question 2 on your worksheet. So the one that's in the file folder that has an answer key already, this full question is very similar in the sense of force x was winning and force of friction was losing. You have to find a net force and then find an acceleration. Okay, cool. Now, I'm not going to finish there for this video. I want to talk about if there's a different scenario. If you were in the lab and you got to kind of do some of this, you got to do a question with me where it still looked all very similar to this, but I'm just going to change these numbers just for the sake, like I'm not going to make a whole new question and go do all over it again because that would take a little while. But let's say in a certain question, our force of friction was 200 and our force x was 150. Okay, so our force of friction is 200. Our force applied in that direction was 150. All right, so let's find a net force. Net force is still kind of, all right, we're going to go Fx minus force of friction, which means like 150 minus 200. So I get negative 50. All right, well, if you went on and kept using negative 50 and then divided by like 25, you get like negative 2. Your acceleration is negative 2. Well, not exactly. In this question, again, if we think about this in the sense of what these forces mean, force of friction is 200, and the force that you're applying is 150. Well, this is friction. Friction is not going to move anything. It's just stopping you. So if force of friction is ever bigger, your acceleration is just 0. You can skip the net force part, and you can go right to the acceleration. Acceleration in this scenario that I just made is 0 meters per second. And then again, that's just because anytime your force of friction is greater than the force applied in that direction, you're always going to have a 0. Okay? So hopefully this helps you with finding the net force out of this kind of problem, as well as kind of understanding the net force and how the back and forth works between the force friction, force X. We have one last video. It'll be kind of finding mu from an angle like this, and that'll be kind of your last video for this week. All right, thanks class. Have a good day.